Why do some people say that South Korea's KF-21 is not a true fifth-generation fighter? According to data released by the South Korean military, the KF-21 was indeed designed to fifth-generation fighter standards. A clear example is its structural design, which includes features such as carrot inlet, canted twin vertical tails, and a diamond-shaped nose cross-section, all hallmarks of stealth technology associated with fifth-generation fighters. However, these design features alone are not sufficient to significantly reduce the aircraft's radar cross-section. One of the key factors in reducing RCS lies in the internal weapons bay. A fighter jet without an internal weapons bay cannot meet the stealth standards of a fifth-generation fighter, no matter how refined the rest of its design may be. So, why does the KF-21 lack a full internal weapons bay and instead use a semi-recessed one? In this video, we're going to dive into what may seem like a simple design element, the internal weapons bay, but which actually involves extremely high technical complexity. When it comes to internal weapons bays, many assume it's not particularly complicated. After all, bombers commonly have internal bomb bays. Visually, a weapons bay might appear to be nothing more than a box that opens and closes at will. Carve out a compartment inside the fuselage, install a hatch, and that's it, right? But in reality, designing an internal weapons bay is technically very demanding. From an aerodynamics perspective, the fuselage frames of a fighter jet are major load-bearing structures, comparable in importance to the keel of a ship. Installing an internal weapons bay means carving out a section of this key structure. From a structural mechanics point of view, this unavoidably compromises the aircraft's overall structural integrity. If the manufacturing and design quality are lacking, using an internal weapons bay can lead to serious stability issues, potentially even mid-air structural failure. Furthermore, the mechanism that opens and closes the weapons bay must function reliably during missile or bomb deployment. While it may not seem difficult to get this working on the ground, fighter jets operate at high speeds. Opening a bay door at high speed instantly alters the aerodynamic profile of the aircraft, producing immense aerodynamic forces and high temperatures on the door's surface. The operational environment is extremely harsh. If the engineering isn't top-notch, even launching a missile could become problematic. For comparison, even a car driving at just over 100 kilometers per hour will experience significant aerodynamic disruption from a slightly open sunroof. Imagine that multiplied many times over on a supersonic jet. This is why, whether it's a large central bay or a smaller side bay, extensive simulation and testing are required, including tens of thousands of hours in wind tunnels, some of which are supersonic. Only after passing weapon release tests across the aircraft's full flight envelope can the design be considered successful. Historically, the U.S. experimented with retractable internal pylons on the F-102 and F-106, storing both pylons and missiles inside a bay. When needed, the bay doors would open, the pylons would extend, and the missiles would ignite. This became the technological foundation for the internal weapons bays seen in modern fourth and fifth-generation fighters. Compared to the F-102 and F-106, however, fifth-generation fighters have even stricter requirements. On one hand, the bay doors must seal perfectly when closed to preserve the aircraft's stealth profile. On the other hand, they must be capable of opening and closing and launching missiles under high-speed flight conditions. At high speeds, the shock forces on the weapons bay structure increase exponentially compared to low-speed scenarios. Issues like door deformation, shifting center of gravity, and stress on the aircraft's main beam must all be considered. Simply reinforcing the structure adds excessive dead weight, creating a huge engineering challenge. Since internal weapons bays are so crucial for stealth fighters and are so technically challenging to develop, how did the US and Russia manage to overcome this hurdle? As the first country to develop stealth fighters, the United States was naturally also the first to tackle the internal weapons bay challenge. During the development of the F-22 Raptor, engineers conducted extensive wind tunnel testing using 1/10 scale models. Eventually, They adopted a solution involving externally extending launch rails paired with titanium alloy fuselage frames. When launching short-range missiles from the F-22 side bays, the aircraft first uses an electronic actuator system to open the bay door, then extends the LAU-142 vertical eject launcher to fire the missile. However, because this type of launcher takes up a lot of space, it significantly reduces the F-22's internal fuel capacity, one of the main reasons behind its relatively limited range. Whether on the F-22 or the F-35 series, the aircraft's main belly-mounted weapons bays all operate using an eject-then-ignite method, where missiles are first ejected from the bay before their engines are ignited. For the F-35, this isn't as big of an issue, since none of the three variants are designed for sustained supersonic dogfights. However, the F-22 was specifically engineered to fire missiles while cruising at supersonic speeds. This presents a level of technical difficulty comparable to a submarine firing torpedoes at depths greater than 250 meters. Although most modern conventional submarines can dive below 300 meters, and nuclear subs even beyond 500 meters, the world record for torpedo launches sits at just 270 meters. In reality, 99% of submarines have never fired torpedoes below 200 meters. Similarly, 90% of stealth fighters have never actually launched air-to-air missiles from internal bays at supersonic speeds. As for Russia's Su-57, it has been significantly constrained by limited R&D funding, making it difficult to employ more advanced technologies. Much of its overall design philosophy is inherited from the Su-27. Interestingly, the Su-27 already featured an open space between its engine nacelles on the underside of the fuselage, and this space could be repurposed into an internal weapons bay, greatly reducing development costs. However, this design choice also came with trade-offs. It prevented the Su-57 from using S-shaped air intakes, which are essential for shielding engine components from radar. As a result, the aircraft's stealth performance is substantially compromised. And that brings us to a critical conclusion. While internal weapons bays are often overlooked by the general public, they represent one of the most challenging and defining features of modern stealth fighters. It's not just about hiding missiles. It's about engineering precision, aerodynamic mastery, and structural innovation, all rolled into one. So next time you see a fighter jet with a sleek, smooth belly and no visible weapons, remember, what's hidden inside isn't just firepower. It's the result of decades of research, trial and error, and billions of dollars in development.